Hello everyone, my name is Vivin Abram and in today's video we are going to do some numericals based upon Coulomb's law and superposition principle. So let's get started. Okay, so before we get into the numerical part, we have to understand what is superposition principle in electrostatics. Okay, now from the previous video we know that Coulomb's law talks about the force of interaction between any two charged particles, right? We know that if I have q1 charge, I have q2 charge, and if they are separated by some distance r, then I can simply find out the force of interaction to be k q1 q2 upon r square. There is a distance between them square, right? Okay, now what will happen if I have more than two charges? Let's say I have q1 charge, I have q2 charge, and I have q3 charge, right? And now I'm supposed to find out the force of interaction of q1 charge because of q2 and q3. Now how am I going to do that, right? So this is where superposition principle comes into play. Superposition principle states that experimentally it is verified that the force on any charge due to a number of other charges is the vector sum of all the forces on that charge due to the other charges taken one at a time. Now what does it say? It says that okay, this q1 charge is going to experience a repulsive force which will be in that direction, that will be given as q force on q1 due to q2. Very similarly, this q2 is going to experience a repulsive force in that direction, which I will write it force on q1 due to q3, right? So according to superposition principle, the net force on the q1 charge will be the vector sum of both the forces. Vector sum of, that is, force on q1 due to q2 vector plus force on q1 due to q3 vector. The vector sum of both the forces will be the answer, right? So you can generalize it for n number of particles. Let's say there are n number of particles, then the net force on any particular particle will be f1 vector plus f2 vector plus so on fn vector. So all the forces are going to be vectorially added, and that will be your final result. I hope that is understandable. If that is understandable, let's go to our numerical. Okay, this is N.C.E.R.T example 1.6, right? So the question says consider three charges q1, q2 and q3 each equal to the charge q. q1, q2, q3 charges are there, and they are assumed to be q charge at the vertices of an equilateral triangle of side L. So here you guys can see in the figure there's an equilateral triangle ABC, and the side of the equilateral triangle is L, and we know the equilateral triangle means all the three sides of the triangle will be of the same side, right? So if L is for one side, that means AC is also L, and BC is also L. I hope that is understandable. What is the force on the charge Q, capital Q, with the same sign as Q placed at the centroid of the triangle? So you guys can see this point is the centroid of this triangle, and there is a charge Q that is sitting. I have named that point to be O, right? So you're supposed to find out the net force on this charge Q, which is sitting at the centroid of this triangle. I hope you got the question. The question is asking us to find out the net force that is acting here. So here we are going to use Coulomb's law as well as superposition principle, right? Okay, so if you understood the question, let's try to solve this, right? Okay, now great. So you guys can see the charge is here at O, right? So this charge Q, which is positive by the way, is going to experience a repulsive force because of the charge which is sitting over here. Yes or no? This is going to experience a repulsive force. This will be force on O due to A, right? Yes or no? I hope that is understandable. Very similarly, this same charge Q is going to experience a repulsive force because of the charge which is sitting over here, right? And which will be in this direction, that is force on O due to B. I hope that is understandable. Yes or no, right? Okay, great. If that is understandable, you guys can see Again, this charge is going to experience one more repulsive force because of this q charge is sitting over here, and which will be in this direction, and let me call that force on O due to C. I hope that is understandable. Yes or no, right? So you guys can see there are three vectors, there are three forces. Let me draw it over here. There is one force FOB, right? There is one force FOC, and there is one force FOA. I hope you guys can see there are three forces over here, right? So if you want to find out the net force will be simply the vector. So the idea is, I hope you guys are getting the idea. The idea is I'm going to find out the net force at O, and that will be simply the vector sum of all the three forces according to superposition principle, right? That is FOA vector plus FOC vector plus FOB vector. All I have to do is add all the three forces vectorially. I hope I'm making sense, right? Clear? Okay. So if that is clear, let's move to the other parts, right? The other part is that we all know that for equilateral triangle, the interior angles are 60 degree, right? All the interior angles are at 60 degree, right? Okay. Now there is this line which is perpendicularly, all the three lines are, you know, dividing this L length into L by 2, and they are perpendicular to the corresponding sides. Yes or no, right? Okay, so when they are dividing, they are bisecting the angle also, right? So they are bisecting the angle. Now here the full angle was 60, half will be 30, right? Half will be 30. Very similarly 30, I hope you guys are following this. 30, 30 and 30, right? Great, right? Okay, now all I have to do is, see, I have to find out this distance, because all the three distance you have to understand here, AO is same as BO is same as OC. All the three distances are same, right? All the three, you have to understand why I'm taking that distance, because they are the separation distance. Why? Because you guys can see over here, this distance is the separation distance between the charge Q and capital charge Q. Similarly, this distance is the separation distance between the Q charge and the capital Q charge. Again, this distance is the same distance between the Q charge and the capital Q charge. So that distance is very important for you guys to understand, right? So how I can find out that distance? I'm going to use simple trigonometry over here, right? So very clearly look at this triangle. Okay, look at this triangle. Look at this triangle. I hope you guys can see the line that I'm making, the gray line, the gray triangle, right? The triangle, I'm talking about triangle BOD, right? In triangle BOD, I know this angle is 90 degree, right? And there is an angle of 30 degree over here, right? So very clearly I can write over here cos 30, cos theta, let me say cos theta, where theta is actually 30 degree, right? So I'll just write cos 30 is equals to, we all know this is the normal shortcut that we use to find out the trigonometric angle. So cos is base upon hypotenuse, right? So base upon hypotenuse is what cos is, right? So you guys can see here angle is 30 degree. So let me just draw this triangle over here, right? So this is the triangle 30 degree, right? So you guys can see this is the base. Now base has a value of L by 2 and hypotenuse is something which I have to find out. So let me call hypotenuse to be H. Okay, all right. Cos 30, the value of cos 30 is how much? I'm sure you guys know. The value of cos 30 is actually root 3 by 2, right? I hope you guys know that, and that is equal to base upon hypotenuse. Now value of base I know, that is L by 2, right? Hypotenuse I do not know, right? So I can find out here hypotenuse to be L by 2 divided by root 3 by 2 or simply hypotenuse comes out to be L by 2 into 2 by root 3. 2 cancels out, so hypotenuse comes out to be L by root 3. Now this is very important. I got the value of hypotenuse, or I should say I got the value of BO. Now BO is equals to AO is equals to OC, so I know the separation between these two charges, which is actually coming out to be L by root 3. I hope this much is clear to everyone, right? So I know I got the separation here, right? Now all I have to do is I have to apply Coulomb's law for each forces. I have to apply Coulomb's law for this, I have to apply Coulomb's law for this force, I have to apply Coulomb's law for this force. Is that understandable? Okay, great. So let's move to the next page. So I will apply Coulomb's law one by one, right? So let's talk about FOA, right? So I will first talk about FOA. So O and A, you guys can see this is O and this is A, right? So there is a charge Q and there is a charge Q. Difference separation between them is L by root 3. This is something which I know, right? So very similarly I can write K Q small q divided by separation between them is L by root 3 whole square, right? I hope that is understandable. Now it is going to experience a force along the force is along in this direction, in the downward direction. Force is along downward direction. You guys can see it's in downward, so you guys can see it is along you guys clearly see it is along AD. It is along AD. I hope you guys are following, along AD, right? So FOA I got, that is K QQ by L square upon 3, right? So if you guys can see clearly all the other FOC, so if I talk about FOC is also the same thing. FOC magnitude wise, if you guys think there is a Q, there is a capital Q charge, there is a small q charge, separation between them is L upon root 3, right? So all the three are having the same, the difference is the direction, right? So FOC will also have 3KQQ upon L square, right? The only difference is FOC is along CF, right? I hope you guys can see CF. Just see it in the diagram, CF, right? Along CF. I hope that is understandable. Very similarly, third one is your FOB is also having the same things, right? So FOB is again 3KQQ by L square. The difference over here is the direction. The direction of FOB is, you guys can see FOB is along BE. Can you guys see BE? I hope that is understandable, along BE, right? Okay, now the important thing, I'll just draw the same diagram here. So FOA is in downward direction. See, FOA is in downward direction, right? And the vector sums are like that. FOB, here is FOB, right? And FOC, here is FOC, right? So I have to just add them vectorially. Now the idea over here is you have to understand what is this angle, right? Okay, by geometry, if you guys can do some geometry over here, right? So by geometry I can clearly see that this angle is 120 degree, right? But you guys can do it up, you guys can try it out, right? Do it by yourself. If you have doubt in finding the angle to be 120, you guys can comment it down, I can explain it to you. But just watch it, try to do some geometry over there, and you will find out the angle between these two vectors are coming out to be 120 degree, right? Okay, great. So if that is true, I can add these two vectors. First I'm going to add FOC plus FOB vectorially, right? So we all know, we have studied this, right? That is FOC square plus FOB square plus 2 FOC FOB, right? cos of 120 degree. Now for all those who do not know what is cos 120, cos 120 is minus half. Cos 120 is minus half, right? Okay, great. So I can just simply write over here 3kq by L square whole square plus 3kq L square whole square plus okay, instead of plus it will be actually, it will be minus half, so minus 2 and 2 will cancel out, and this will be minus of 3kq upon L square whole square, right? And you guys can clearly see this will cancel out with this one, right? And you will have the final answer will be FOC plus FOB to be 3kq upon L square, right? The same answer you will get. Now the important thing is, you know, by triangle law, sorry, not triangle law, by parallelogram law, you guys can see by parallelogram law the resultant will be in a straight line. Yes or no? By parallelogram resultant vector will be along the diagonal, right? And it will be in the straight line, right? So you guys can see this, I have vector and I have this FOA and I have this F resultant, right? So both have same magnitude, and they are in opposite direction. So the final answer will be FOC plus FOB plus FOA, that is the third vector. When I add, both have same, you know, magnitude, but the directions are different. So when I add, the final answer will come out to be 0 vector. I hope this is understandable. The final answer will be 0 vector. Is that understandable? I hope that is understandable, right? Just go through the solution once more so that you guys can understand it. I hope that is understandable. I hope all of you are doing good. Stay home, stay safe.